Welcome to this video. In this video, we are going to learn about the probability and statistics. Okay, what is meant by probability? It means that it is a chance. Okay, before going to introduce the basic concepts of probability, first we know the basic concepts of experiment, trial, sample space, event, equally likely events, mutually exclusively events, favorable events, exhaustive events, and independent events. Okay, trial means performing an experiment, we get a trial. Sample space means total all possible outcome of an experiment is called a sample space. Event, it is a subset of a sample space. Next one, equally likely events, when none of them can be preferred rather than the other. Mutually exclusive events means if they cannot come together, they cannot come simultaneously. Always we consider single trial. For mutually exclusive events, we consider single trial. Favorable events, it is the number of outcomes which entail the happening of the event. Next one, exhaustive events, all possible outcome is said to be an exhaustive event. Next one, independent events. Independent event means two or more events can consider if the occurrence of the one does not affect the occurrence of the other. Okay, now we take the mathematical definition of probability. Let S be the sample space and capital A be the event associated with the random experiment. Next, P of A is equal to favorable cases of our N capital A divided by exhaustive number of cases in S, that is N of A divided by N of S. Okay, which is the mathematical definition of probability. Next one, axioms of probability. Let S be the sample space and A be the event associated with the random experiment. Then the probability of the event A denoted by P of A, and it is defined a real number satisfying the following axioms. The first one, always the probability of the event A lies between 0 and 1, that is impossible event to sure event. Second case, total sum of, that is all sum of all values is equal to 1. Third one, if A and B are mutually exclusive events, then the addition theorem of probability can be written as P of A union B is equal to P of A plus P of B, since P of A intersection B equal to 0. Okay, now we consider set sample space S. In that sample space we have two events A and B. Okay, the intersection of these two events we get 0. Therefore, the probability of P of A intersection B equal to 0. Okay, depends upon this. We have some notes. First point, probability of impossible event is always 0. P of pi is equal to 0. Second point, if A bar is the complement of A, then P of A equal to, or P of A bar is equal to 1 minus P of A. For example, we consider the sample space S, and in that sample space we consider one more element or one more event A. Other than that A is A bar. For sum of these two probabilities, that is P of A plus P of A bar is equal to 1. But equal to 1 is your P of S, that is sum of all sample space, that is total probability of sample space. From the axioms of probability of a second point, P of S is equal to 1. Therefore, P of A plus P of A bar equal to 1. P of A bar is equal to 1 minus P of A. Similarly, our third one, B is the subset of A, then probability of P of B less than or equal to P of A. So we consider one sample space. In that sample space we have consider one more event A. Again, in that event contains B, since B is a subset of, that is B is a subset of A. So probability of B is always less than or equal to probability of A. And fourth one, P of A intersection B bar is equal to P of A minus P of A intersection B. We consider the sample space S. In that sample space we consider two more events, capital A and B, and this is denoted as our A event and this is B event. Our common portion is A intersection B. Now from this we can write capital A is equal to A intersection B bar union A intersection B. Therefore, next step, taking probability on both sides, P of A is equal to P of A bar intersection B bar plus P of A intersection B, since these two events are mutually exclusive events. So, we can write P of A is equal to P of A intersection B, P of A is equal to P of A intersection B bar plus P of A intersection B. Now, modify this equation like this, P of A intersection B bar is equal to P of A minus P of A intersection B. Next, independent events. If any two events are said to be independent event means P of A intersection B can be written as P of A into P of B. Okay, now we are going to discuss some problem based on the axioms of probability. Now take down the first problem. Find the probability of getting 53 Sundays in an ordinary year. Okay, now the solution is total number of days in an ordinary year is 365 days. Total number of days in an ordinary year is 365 days. Okay. In 365 days, we have 52 weeks plus 1 day. The remaining 1 day may be, maybe Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. Let A be the event of getting Sunday. Okay, the corresponding probability N of A is equal to 1. Therefore, probability of P of 53 Sundays in an ordinary year is equal to, our favorable cases is the 1 day may be 1 Sunday, N of A divided by total number of days in a week is 7. Therefore, 1 by 7 is our answer. Similarly, shall we pass on to the next question? From a set of 17 cards numbered 1, 2, 3, etc. up to 17, one is drawn at random. What is the probability that the number is a multiple of 3 or 5 or both? Here we have a set of 17 cards that will be numbered like this 1, 2, 3, 4, etc. up to 17. What is the probability that the number is a multiple of both 3 or 5 or both? Now the solution is, the sample space contains 17 cards. Therefore, N of S is equal to 17. What is our A? Our A is the number is a multiple of 3 or 5 or both. Okay, from this sample space we have to select the multiple of 3 or 5 or both. 3, 5, 6, 9, 10, 15 or also 12. Okay, 3, 5, 6, 9, 10, 15, 12 are the multiples of 3 or 5 or both. So, N of A is 7. Therefore, the probability of the number is a multiple of 3 or 5 or both is equal to, our favorable cases is 7. The total number of cases, that is the total number of outcomes is 17. But answer is 7 by 17. Okay, one more question. A committee of 5 is formed by drawing a lots from 8 boys and 6 girls. Find the probability that the committee will consist of 2 boys and 3 girls. A committee of 5 is formed by drawing a lots from 8 boys and 6 girls. But total number of persons are total number of persons are 8 boys plus 6 girls, but totally we have 14. Okay, n of s, you are selecting 5 ways, 14C 5 ways, you are selecting this combination, 2 boys and 3 girls. The corresponding 14C5 answer is 2002. Let A be the event of selecting. A committee will consist of, will consist of 2 boys and 3 girls. Therefore, n of a is, okay, totally we have 8 boys. From that 8 we have to select 2 boys. It for 8C2. Our combination is 8C2 and 3 girls. Out of 6 girls we have to select the 3 girls. So 6C3. Okay, n of a is 8C2 into 6C3. Therefore, the probability of the committee will consist of 2 boys and 3 girls. So 8C2 into 6C3 divided by 14C5. 8C2 value, we want to calculate the 8C2 value by using the NCR formula, n factorial divided by r factorial into n minus r factorial. That is 28. Similarly, 6C3 is 20. Therefore, our answer is 8C2 is 28, 6C3 is 20, but totally product of these two, 28 into 20 divided by 14C5 answer is 2002, 560 divided by 2002. Okay, this is the probability of forming a committee will consist of 2 boys and 3 girls.